Hi, Jeff Burke here from Broadband Forum. We're here in Milan, Italy for our Q3 meeting, and we're here to actually walk through an amazing demonstration that was pulled together particularly for this meeting by OutSys. And I'm here with actually the partners of OutSys. We have Fabrizio, Ernesto, and Fabio. Hello, gentlemen.
Hello.
Hello.
Hello. And they have pulled together a really amazing proof of concept of broadband QED, or Quality Experience Delivered. You may remember this from something that we introduced at our Q4 meeting in 2018 in Glasgow, Scotland. Over the course of the last 9 months, they've been actively working from turning that concept into reality. And they brought it here to the meeting. We've had a lot of interaction with members of both service providers and ecosystem partners having to take a look at it. And I think the overall feeling was that you've really pulled together not only the first of its kind demo in the world, but something really truly special. So congratulations to all of you. It's fantastic. So what I'd like to do is actually have this team walk us through the proof of concept today and share with you really what this exciting news is all about and where we're going to take it from here. So if you don't mind, Fabrizio, why don't you start to walk us through what, maybe you and I can first talk about for a second what broadband QED is from your perspective, and then maybe we'll look at what the proof of concept's all about.
Okay. The QED is a new means of measuring the quality of the network. It has to do with the latency, but the key part is that is able to separate the key parts in 3 major segments. One segment has to do with the physical part, the distance between the objects. The other part has to do with the size of the data that is transported, and the last part has to do with the variable part, which is the network congestion, the queuing, and stuff like that. It's important to know this difference between the parts because there are some parts that you can work as much as you want, but you cannot improve that. The distance between 2 points, it will take always the same time, and so the effort will be useless. Using normal measurement tools, normal measurement instruments, what you get is a flat measure, and you cannot separate that. This is important because a lot of effort goes in that activities. It is absolutely useless.
I know that a lot of what the service providers were talking about at the first sharing of this concept was that too often broadband had been really looked at as just an improvement in speed, and as applications had gotten more complex and more and really more advanced, all these elements of latency and jitter and other things that you're measuring now can be really looked at in a very granular manner and really be turned into a better quality of experience that is really complementary to the speed of the network itself.
Yes, of course, that's one of the main points that you have to look at. You need the whole picture. You don't just have to concentrate on one part. And the quality, the QED, gives exactly that tools. It gives meaning of what you're measuring.
Well, let's take a look at what you pulled together here. I think there's an overall network that you've emulated. Yeah. So let's take a look at each individual part.
Okay, the important part is that, we have done the prototypes that works on the QED, but we also need to prove that these prototypes works. So we have built a test bench that is a small scale service provider, typical wide area network. We will start with this object. This object it is the orchestrator of the QED, and it is located in the core site of the service provider. Then we have got here a core router, which is the access to the core site of the service provider. We move toward southbound. We have got here the broadband network gateway, which is the router that is used to collect all the logical lines from the subscriber to bring it to the core network. Here we have got the devices that are used to give the connection to the last mile. We have got DSLAM, which it works on copper, and we have got a GPON that works on fiber. And here we have got the bridges, the bridge, of course, copper and fiber. And then we have two different households. One which is connected via copper, and the other it is connected via fiber. And we have got the CPE, of course, and after the CPE we have got what is the endpoint devices, which is it is representative of a PC or a server or whatever you have at home, a telephone or whatever. The important part is that you can take measure on every pieces that you have got in this emulated LAN. WAN. It is, and then you can work this information to obtain the quality, the QED that we have implemented in our prototypes.
Well, it's a very expansive, impressive setup. I mean, you have literally each and every part of the network, all the way from the core and central office, all the way through the individual device at the end, and you're sampling pieces of information at each component, and then feeding it back into a software capability that basically interprets what this all means.
Yes, exactly. And also we have got in every segment we can introduce latency, we can introduce packet loss. Every juncture of a section of the network can be controlled to add the quality attenuation that we need to test, which it means that really we can generate any situation that we have in a real network, and to see how it works out in terms of quality.
And to the best of my knowledge, this is the first time anyone's ever implemented this or instantiated this physically in the world.
Yes, I think this is the first practical implementation of the QED. There are other implementations of the QED that are working right now, but it is just like a standalone application. This is how it can work in a real network, because the instances of the software, the prototypes, runs on each of these objects. So you can take measure not just from the core to the edge, but you can take from the segment, for instance, from this household, you can take a measure to this household as well. For the house is not really important, but is important for the business, because for instance, some business that runs on MPLS or something like that, they want to know how long does it take, what is the latency between their sites, not the latencies between one site and the core of the service provider. They're not interested about the core of the service provider. And also these prototypes runs on cloud platform server, so you can also take a measure outside the network provider networks and see how it works. If, for instance, you are a company that have got instantiated some services in the clouds, you are not just interested in the part of that is provided by your service provider, but also how it works to get to the cloud platform. You can do that with what we have. Of course, it is just a prototype right now, but it was important to prove that that could be done. There is value in the concept. And also, I think it's important for the broadband forum as well to show that what is done is really meaningful for the industry. It is not just some theoretical opinion of some guys over there.
Well, I think it might be worth discussing that for one moment. I mean, I believe, if I know the story correctly, you were sitting in the room when Vodafone really brought this concept to the forum itself at the Q4 meeting, and you went back to your partners and said, could we do this, right?
Yes.
And ultimately,
as a matter of fact, I am a skeptical guy, so I saw the concept. I saw some value in the concept, but my idea was, does it work? So in our team, we have got people that are more knowledgeable than I am in mathematical models and so on. They told me, yes, it can work. There is real stuff here. And so I thought, let's try to do it. They said, you are crazy, something like that. But no, they didn't say
Well,
that.
now you proved them
No,
wrong.
they didn't say that. They said that it was interesting, and that was the point. It was just to prove that there was value. It was just not a theory.
Well, now what I think is interesting is that you've taken it to this point now where today I saw service providers from all around the world engaging with you very deeply in how this works and how it ultimately would manifest itself in their network. So
We were surprised. We were surprised about that because when we decided to do this demo, we didn't know what. First of all, it was a challenge for us to see we can do that. We have done that. Let's do something that is meaningful, not just for ourselves, for the other. But when we brought here this solution, this idea, we got a lot of feedback from the service provider. They were really engaged, interested. And we got very interesting questions that it meant that they were up to what we are talking. We were on the same line. They weren't the usual question, okay, let's see what you have done. They were very challenging questions. They were just pointing out, we will see afterwards on the diagram and saying, what does it mean? It doesn't make any sense. We had to prove that it was meaningful.
well, let's now that you've shown us all the equipment, let's see what it means. Want to take a look at the software? Let's take a
Yes,
look.
of course.
walk
I
down
will
there.
pass that to my colleague. That, as I said, you are much better in this stuff than I am.
Okay, great. So let's take a moment and what are we looking at here, and what's going to be shared with us?
Here we look at the console of our application where we schedule test campaigns and where we schedule everything that we'd like to know about our network. So during these days we did some tests, and for example, this is a scenario that we did. The ideal customer that calls and says, hey, I have a problem with my network, it's going slowly. And so we look at the data, and in fact we can see that the split of the delta Q in the GNS and V part has got a hit at a certain point in time, and the G part increased a lot. So yeah, it's true, they're actually having a problem. But if I look at the data of the CPE, then the CPE is flat. The CPE is not having any impact at all. So, dear customer, yes, it's true. You have a problem. That your internal routing is wrong. The packets are bouncing back and forth, but it's your problem inside your network because my network, up to the point where I deliver the packets to you, works fine.
So you've isolated where exactly in the network the challenge lies, and now what's the next step for the service provider? To go to that point of the network and see what levers they have that they can utilize to address it, right?
Exactly. That's exactly the point. So understand where the problem is, how the problem was caused, and then, of course, try to solve it if it's affordable.
Right.
Another scenario was MPLS-like connection, so the connections between one site and another site, two customer sites. So our probe don't work only from a central site to somewhere else, but they also work in MPLS-like scenarios. And here we can track, for example, the distribution functions of packets. So how long it takes for 90%, 95%, 98% of the traffic to go from one side to the other. Of course, always uplink and downlink, because we are able to split the up and downlink. Because nowadays, networks are not symmetric anymore. So the difference between uplink and downlink is important, and it's important to show the difference. So we can see how it moves and, well, how it goes. And another nice scenario that we did is how to link the delta Q with other measures of quality of the network. Here we have MOS, for example, audio MOS. And so we can see how the variable part of delta Q, its average and its standard deviation together with packet loss clearly shows the degradation of MOS. So MOS that was 4.5 at the very beginning, when we added some noise, it goes down and up. So we can see that thanks to delta Q, we can also explain the other different measurements, old measurements, let's call it this way.
Understood. Can you go back to the previous screen? I wanted to ask you just a color thing. I had learned this from the first time you all walked me through this demo, that the screen that had the 3 colors on it, You were just there 1 second ago.
First one? Okay. Perfect.
Yes. So my understanding was, as you're looking at these, some of this, the green was maybe things that were due to distance, so you may not be able to affect directly, but blue and red meant something else, that you could actually more aggressively impact that in the network. Is that correct?
That's correct, especially the red one, because the green is basically due to physics, so it takes time to go from one side to the other one, and speed of light cannot exceed a certain limit, so that's it. The blue, it represents the time it takes to send the packet to the network, serialize it and deserialize it. And of course, the larger the packet is, the longer it takes to serialize it. And you can reduce the number of routers it goes through so that you reduce the number of serialization that you have. But apart from that, you have to deal with it. And the red part is the variable part that is due to enqueuing inside routers or scheduling or anything bad that happens on networks, and that's the part that you can actually work on for sure. But also the other part are not meaningless. I mean, if you have different sites that have physical similar distances but have different G sides, then it means that maybe one of them has a higher G than the others. Mm-hmm. It means that that G can be addressed because it's the same distance as the other ones. So you're measuring a different distance. It means something is strange, at least in the routing that you have on that link. So all of them are important. For sure, that the easiest, let's say, to look after is the variable part, yes.
Well, I think that now that we've seen the network itself, the proof of concept, and then how the data is extracted and then presented, I mean, to me, the implications are huge. I mean, you could affect, very easily use this data to improve support. You could improve the overall experience of the customer itself. You could use these for customer retention in a number of different ways. You could even tailor different service packages, gaming, et cetera, that were really based almost exclusively on the data that you were extracting from this, and utilize this in many different ways across the service, within the service provider, both from an operational and even a marketing and sales perspective. Do you agree with that?
I completely agree. It's a sort of MRI of your network, and by analyzing it and getting not only data but information out of it, it's a great plus for a service provider.
All right, well, great. Well, I want to congratulate the OutSys team on pulling this all together. It was a great accomplishment. I think as an example of, as I mentioned, the first example in the world of bringing broadband QED to life, right? And it really has a very, a very promising future. And certainly from what we saw today with the reaction from both the service providers and the ecosystem partners I saw you all talking with, it looked, I'm really excited for you.
Thank you very much.
All right. Well, with that, this is Jeff Burke signing off from Milan in our Q3 meeting. And I hope to come back in a couple of quarters here and give you another update as to where broadband QED is going. Thanks again.